Hello everyone, in this video I will show you how to implement A-star algorithm in Python. Before moving ahead, I would strongly recommend you to watch the video given in the description which contains the idea and working of A-star algorithm. So once you have understood the working of A-star algorithm, it will be easy for you to write the code on your own. Okay, so before moving we have this driver code which contains the cost in this particular pattern. There is a different methods to calculate this heuristic value. I am going to hardcore this value right now, but in order to calculate it, you can just find other video source that I have given in the description below. So let's get started. First, we will initialize the required variable. So we will require path list, which contains the path from the start to the goal, and will also contain path set. This will hold all possible path that can be drawn from the start node to the goal, any one of the goal state. We'll also require two more lists, open list and closed list. So this open list is used to keep track of the unvisited nodes. Similarly, this closed list is used to keep track of the visited nodes or explored nodes. We will also require a path length. This will contain the length of the path so far. So let's say you are in a node, third node, and from start to the third node, what is the total path cost? So that will be added up and will be maintained in this particular length. So always we will initialize this path length for the start node, which will be 0 because there's no path behind it, so it will be initialized to 0. So we will write the main logic in the while loop, right? So until the length of open list is greater than 0, we will have to do some steps. First of all, we need to choose a node from this particular open list. So now we will also write one more function, helper function. This will be called as f. This is the f value that is required to calculate the next path, to choose the next node. So this will take three arguments, g, h and n. So f of n is basically g of n plus h of n. Once you understand the working of a star algorithm, you know why we require f of n node. So let's say node equal to none. Now we will run a for loop for node n in open list. Because we need to choose the one node which contains the least possible f value to get the optimal solution, right? So we will check if n is we'll check the node, right? If node is none, meaning if this is the first node, means there is no node that have been chosen. So if n is the first node, we'll just simply initialize it. We'll simply initialize the node to be n. Or if it is not the first node, right? If it's the first node, we will just assign that particular node. Otherwise, we have to calculate the f value for it. So f of path length, we'll pass g as path length, h as heuristic, and the node, the current node n. If this value, if it is less than, same f of path length, heuristic, and for this node, whatever the node, previous node, right? So if the current node's f value is less than the previous node's f value, in that case we will update the node as the current node, which is having the least f value, correct? So now if you say there is no such node found, right? And if you say if the node is none, after this calculation, if the node is none, there's no node present, which means to say that uh, no path exists, from start to the goal, no valid path exists. So we just simply break, right? If this is actually none, we will just break it. Okay, make sure they put this outside the for loop. Now we will check if the node is in the goal state. So if node in goals, we will store the value of store its f value. So calculate f value by this function f of path length, heuristic, and node. So we'll calculate the f value for this particular node, okay, and this will be kept in fvn. Now we will also create one more list called reconstruct. This will help us in retracking the path from the current node to the start node. Now we will also require one more dictionary here called parent node. This will actually help us retrack for the backtracking purpose, right? So we'll keep the parent node of the current node in this particular dictionary. So parent nodes of start. What is the parent node of start node? We will just keep it as start itself. Why? This will help us to break out the while condition that we create here. So first we will just say aux will be the current node. So while, as I said, parent node of aux is the node which you are right now here. If this is not equal to the aux itself. So this is basically used for this particular termination condition. That's why we initialize it. Instead of making it 0, we'll initialize it to the same value. So since the nodes are unique, you can actually do this. This is basically similar to traversing a linked list. If you have studied, by keeping a current node, we will execute some function or some operation here and we'll shift to the next node like that. But in a reverse way we are doing, that's it. So what we'll do is reconstruct dot append the node aux. Now you will have to change the aux. So aux equal to parent nodes of aux. So that's it in the while loop. Now let's see how it works, how it's working. Let's say for example, I'm having the source node like this. Let's say this is a start node with a f value of this, and there's no other node for it, parent node. So this is s itself. If I say another node with a, and this is having 6, and let me say this contains s as its parent node. So in this case, for the first time, the aux will be the node a. Okay, so the parent of this aux will be what? This is the parent of the aux s. So this is not actually equal to whatever the current node it is. So we'll actually push this particular a. Remember, this aux is nothing but just a. It's not the entire list, entire set over here. So a will be pushed into this particular reconstruct. So this will have a, and then we will go to the aux as parents of this. Parent of aux is what? S. So this will point to this particular node s. So this again, it check the condition parent of s if it is same. So here we see s is equal to s. So the start node is not basically get pushed to here. So once the while loop ends, we'll have to make the start node pushed in this particular reconstruct list. So we'll append the start node. We can also append aux directly. It need not be start, it's aux. Why? Because it's the last node which is not being pushed inside that particular list. So we will have here, we will have this a and s will be there in this particular format. But what we want as a path is from the starting node to the particular goal node, right? So let's say a is a goal node, right? So we will have as. If you have any other node, we will have let's say here b, right? We will have one more node c. So what we need is from s we reach c, then b, and then a. That's how we need to get. So what we will do, reconstruct dot reverse. This method will reverse this particular list from a b c s. It will become s c b a. So that's all. And now we have got the path from a source node, but this is not an optimal path. So to do this, we will actually have to insert this in the path set. So path set dot append reconstruct. We have to append reconstruct as a set, as a tuple. So reconstruct, and we will also append the f value that is calculated for this particular node over here. We have calculated the f value. Open list will have initially a start state. So there's only the start node will be there in the open list first, and whatever the explode node, that will be come in the closed list, right? So once we explode, here the node will be explode. We'll create a function, let's say update to remove, to add, and what we need to do with what node. This is the node. So we will say to remove dot remove m, and to add dot append m, update open list and close list and node. So here it's clear. Update in the sense we'll say open list dot remove the current node, close list and add the node. So basically we take the list within the open list and it will push it to the close list. That's it. So now the node, if it is a goal state, we have covered that particular part. Now what if the node is an intermediate node, not a start or not a goal state? So we have to do it in this particular case. We will get the path cost equal to cost, whatever the cost for the node is. So we will get it like this, right? So the cost is here. So if you say for first second node, this will be the cost, second node's value, right? So second node's cost is this, which will say from second node to the third node we have 3 as the cost path, path cost, and for the 3 4 5 sixth node the path cost is 9. So that's how it is interpreted. Then we will have to, okay, once you have this particular node in the goal state, we will not have any other further nodes to be calculated from this particular goal. I mean, we don't need to expand any node, right? So here we'll actually say continue to prevent it from going from below below quotes. Now we have to iterate over these node values to get which is the optimal path to choose. So first we will write for m in range of from 0 to path cost, right? So len of path cost, we will calculate the weight is calculated of path cost of m. So this m is basically the index, so I'll just write index, which is basically gives the nodes over here, source node, or you can also call adjacency node, whatever. So path cost of this index, we'll check if m weight is greater than 0. We will check for one more condition. If this particular index, if it is not there, or if it is not in the open list, or the index is not there in closed list, means it is not present in both open or closed list, means it is a new node that we are encountering. What we'll do is we push that to the open list. So open list dot append index. Now we will also have to update the these two values, path length and path parent node of this particular thing. So parent node of this particular index will be the, and the path length of this, path length of the index, how will you calculate? It's the path length of the parent node, path length of the parent, which is this, path length of the node, which is because for this index this node is a parent node, so path length of this node plus the current weight of the index. So you will understand this calculation only if you have gone through the working of A star algorithm. The video is given in the description, you can check it out, because it is clearly explained in there, like how to calculate all these values. Else, now we will check one more condition. Check for the path length. If path length of the index, if this is greater than the path length of the node plus the weight, means we need to update the path. So we'll just assign the path length of the current index to be the sum of the path length for the node and the weight, means this is the shortest one, right? Okay, now we will also update the parent nodes of index. This will be the node. Okay, now after this we will also check if this index, if it is also present in closed list, means if it was originally present in the closed list, what we need to do is we need to update the list. So update closed list, open list, and the node, that is index. what we do here is we will remove. So remove it from the closed list and add it to the open list. So why? Because this index may not be may need to be explored again to find the new shortest path. So that's why we will do this particular condition as well. So once the for loop ends, we will also update the lists. So update open list, closed list for this particular node. Okay, this will remove the node from the open list and add it to the closed list because it says that we have already explored this particular node. So that's all the whole logic in this particular search. I will also brief this out once again. Let's say here we have all this particular initialization happening, and then the while loop actually goes until or up to the open list is not empty, right? If it has any element in it, and we choose the first node as none, and we go with the for loop to find the minimum f valued node, and this condition basically makes that possible. So we have declared our utility functions, or basically the helper functions here. One is to get the f value, and the one more is to update the status of the list. And finally we have the goal. The node is, if it is present in the goals, then we have to retrieve the path that we have come from the source node or the start node to the current goal node, right? And that to do that we will require one reconstruct list, and then we will use this particular traversal method, which will keep track of this which will make use of this parent node to get the parent of the current node, right? It is used to backtracking method, and then we will actually do the logic over here. Finally we will add this particular reconstructed path to the path set. So this path set will have the reconstructed list with its f value. Finally we will update the list, I mean the open list. Okay, so if this is the case, if the node is the goal node, we will actually continue. Why? Because we don't need to execute the below lines. If you don't want to put a continue over here, just put an else for this particular if and put all the code below to that. That's all the same thing. Okay, if the node is not a goal node, it is an intermediate node. In that case, we'll check, or if it is any other node, we will get the cost of that particular node. For this case, there's an example over here, and then for we will run a for loop from the till the range of this path cost, I mean to the entire indexes from this. So we will get the weight of this each index, and we will calculate if it is greater than 0 only, because if it is 0 or less than 0, this is -1, the path or the node does not exist. If it is 0, basically it says that it is a self loop. I'm not sure, but yeah, it should be a valid positive integers or floats. That's an assumption I made it. Okay, so if it is greater, then we will check one more condition if it is present in the open list or not. So if it is not present in the both of the list, in that case we will just put it in the open list, which says it is yet to be explored, and then we will update its parent node and the path length. If it is not present, else means if it is actually present in the closed list or open list, and if the path length is greater than the the current calculated value, we will change it to the minimum possible one right here. And then if it is in the closed loop, we will update this, and again finally we'll update the main node as well. Okay, now we will have been generated the path set which will have something like this and so on. Okay, so what will this set will contain? It will contain a list and a number, let's say 2, and let's say here we will have one more list which says 8, so on. Okay, let me say 12. Okay, so this thing is the list here is a path, and this is the f value of it. So we need to get the least path with the the path with the least f value. So to do that, we will actually sort. So we will check if the length of the path set, if this is greater than 0, means there is at least one node existing. One, you can also check for greater than 1 as well. In that case, what we'll do is we'll set path set equal to sorted. Basically we need to sort it, right? So sort or sorted path set, again path set, and we need to sort with the key of lambda x, where x of 1. So what is this x of 1? This is basically the index representing to be sorted, right? So we have this particular path set which contains a tuple. Each element here is represented as tuple. So inside this we have x of 0, which is the path, x of 1, which is the path f value. Okay, so this we need to sort based on this particular one. Okay, once you understand how this is working, we will need to set the path now. So this path will be assigned to this path set of 0 0. So this indexing, first indexing is for the first element. Okay, once it is sorted, this will be the first element if you consider only these two elements, because 8 is smaller than 12. So this will be the first element. Out of this, we need the 0th index of this value, which is the list, path list, right? Exactly, this is the path list. Else means if it is there's no path existing, we'll just set the path as this. Now we'll just return path. That's it. I think this path is not required from here, because if you append this value, I try to append it, but you will what you get is the list itself. So that's all the code. This is the basic code which returns the path. Let's try running it. Okay, this one error I found here is index not in open list. It should be and over here, and it should not be both. It should not be present in either of open list and closed list, right? So that means it should be a and operator. Okay, let's try running it. Python a star implementation dot py. So 1547, this is the right output for this particular example that we have taken. You can also give your own set of inputs and check for the uh, outputs. Take some simple inputs and try for your, practice on your hand, like how it is actually working, and then you'll get the code easy. So that's it. Hope you like this video and hope the concept is clear. Finally, I will also provide with this particular source and references that I have considered for this making of this particular video. I have the code references as well as the YouTube video references for learning how it actually works, the traversal algorithm, as well as the calculation of heuristic functions, right? This is very important. This is just hard-coded value. You might also require to calculate your own heuristic values. So that will be given in the description as well as the comment section. So thanks for watching, guys. So that's all for this video, and thanks for watching.